Okay, students, today we're going to be talking about writing chemical formulas. And we're not going to do all of these notes today. We're going to save these ones down here that deal with the polyatomic ions for later. Keep in mind one of the rules. We know that these involve polyatomic ions because they end in either ate or ite. And our three that we have to remember are cyanide, ammonium, and hydroxide. So there's our cyanide. So we're going to save those for a later date, but we're going to look at the ionic compounds on top and the molecular compounds that come later today. Remember that we can tell if it's an ionic compound or not if it starts with a metal. If it starts with a metal or it has the polyatomic ion ammonium in it, then we know it's going to be an ionic compound. So all of these first compounds here are going to be are going to be ionic compounds because they start with a metal. The first thing that I want you to do is to write down the ion symbol for each of the elements in the compound. Remember, you have a chart, and I'm not going to keep referring back to this chart. I'm just going to tell you that I'm getting the charges from the chart. Remember, we have this chart that has our common charges for the different groups. We have plus ones here in group 1. We have plus 2s in group 2, plus 3s in group 3. We have a big question mark on group 4, negative 3 for group 7A, or excuse me, for group 5A, negative 2 for 6A, negative 1 for 7A, and of course, pretty much we're not going to get compounds formed from the noble gases. Maybe you'll see one from xenon or radon once in a while, but now that whole sea of unknown charge in the middle, all this area right in here, these are our ones that we don't know the charges for, but if they present themselves, they'll probably be presented with a Roman numeral, so we'll know their charge. Unless they're one of these red ones that I have blocked here. These are what I call the always true. So those are the ones. Silver is going to always have a +1. Cadmium, zinc always a +2. Aluminum a +3. I know it's in the +3 column, but what that indicates to us is that we don't need to show, remember, its Roman numeral with it when we write the name for it later. Okay, so we look at the first one and we have calcium. If you look back at your periodic table, you'll see that calcium's in group 2A, so it's going to have a 2+ charge. Oxygen in group 6A is going to have a 2-. So our big goal in these compounds is that these charges add up to 0. If it already works, don't fix it. We've got two positives and 2 negatives. Already works. Just leave it alone. We simply write calcium and oxygen together for its formula. Notice that the charges do not show up in the final formula for the compound, so do not put them there. Aluminum nitride. We look up aluminum and it's got a 3+ charge. We look up nitride, remember, is the ending name for nitrogen. We look up nitrogen, it has a 3- charge. And so once we have that, we notice that it has, again, a 3+ and a 3- already equals out to 0. So this tells us, once again, if it works, don't fix it. The formula for this compound is AlN. But what happens when they don't add up to 0 to begin with? What do we do then? Well, let's look at the next one, sodium sulfide. Sodium, we'll look up sodium. It has a +1 charge. Sulfide is the ending name for sulfur. We look it up and it's in the 2- column. Now what that tells us, we've got 1 positive and 2 negatives. We've got to have these equal out to 0. How are we going to do that? Well, the only way to do that is to add another sodium with a positive charge. We can keep adding ions, as many as we want, until we get those charges to balance out. By doing that, we see that we've got 2 positives now, along with our 2 negatives. That balances out, and we simply count everything up. We know this compound is going to have sodium and sulfur, but notice there are 2 sodiums here. We need 2 in our chemical formula. Try iron 3 chloride on your own real quick. Remember that Roman numeral 3 tells you the charge of iron. So pause it real quick and see if you can do it. So hopefully you realize that you didn't even need to look up iron. It automatically tells us with that Roman numeral 3 that it has a 3 plus charge. We look up at chloride, the ending name for chlorine, and it has a -1 charge. So we've got 3 positives but only 1 negative. So how are we going to fix that? We're simply going to need more chlorines. We need another negative charge and yet another negative charge. If we have all 3 of those negatives, we'll now have 1, 2, 3 negatives and 3 positives. That balances out. So we know that this compound has iron and chlorine in it. We've only got 1 iron, but we've got 1, 2, 3 chlorines. So that's going to be the formula for our iron 3 chloride. Lead 4 oxide, similar. That Roman numeral 4, remember IV stands for 4. That tells us that we have a 4 plus charge for lead. We look up oxygen on the periodic table, and oxygen's in the 2 negative column. So with that information now, we need to get this to equal out to 0. Looks like the only way we're going to be able to do that is to get another oxygen ion present. If we do that, notice now that we have our 4 positives over here and we have 2, 4 negatives for our oxygens. We know the compound contains lead and oxygen, and with our 2 oxygens that we have, our formula for lead 4 oxide is PbO2. Try the next one. If you can do the next one yourself, you can do any of them that are these binary compounds. So try that one real quick on your own. So this one was a little bit more complex. We've got nickel with a 2 plus. Phosphide is different from phosphate at the bottom. Phosphide is just the ending name for phosphorus with a 3 negative. So what did you do with that one? Well, hopefully you realized, okay, we've got 2 positives and 3 negatives. We don't have enough positives, so we need another nickel. Now we have 4 positives and only 3 negatives, so it looks like we need another phosphorus. Are we done yet? Nope, because we've got 2 positives plus another 2 positives. We've got 4 positives on the left, and we've got 6 negatives. So we need more positives. Excuse me. So adding another nickel onto that, now we notice that it does have 6 positives and 6 negatives. So counting up, we see that it has nickel and phosphorus, 3 nickels, 2 phosphoruses. That's the formula for that compound. So now let's go on. Let's skip down here. We'll cover these polyatomic ion ones later, but let's skip down here to the molecular compounds. Remember, we know that it's a molecular compound if it's all nonmetals. All nonmetals, and it does not have ammonium in it. It's not got a polyatomic ion. In order to do molecular compounds, these are the easiest ones. The ones up above, we had to know charges and everything, but for our molecular compounds, they're so easy if we know prefixes. If we know this information right now, and you will be expected to memorize this, if we know this information right here, we'll be able to easily write the formulas for these compounds. If the first element, if there's only one of the first element, it won't have a prefix. So as soon as it says carbon, we know that it's just 1 carbon. The second element will always have a prefix. In this case, it's di. So that disulfide tells us that it has sulfur and that there are 2 of them. Dinitrogen tetrahydride, that di and tetra tell us that for nitrogen, di means that there are 2 of them. If you look in the table above, tetra means that there are 4 hydrogens. So that's the formula for our dinitrogen tetrahydride. So why don't you pause it real quick and see if you can do the last 2 on your own real fast. Hopefully you realized that with the di and the tri here, that phosphorus. I got a little carried away on the name. It looks like I've got diphosphorus, but we've got phosphorus, and there are two of them. And trioxide, there oxygen with 3, so P2O3. And finally, xenon, Xe. Since there's no prefix, that means there's only one of them. Hexafluoride. Remember, fluorine is just F. Please don't put in that Fl. Get that? That happens all the time. So we've got xenon with fluorine, and since it's hexa in the table above, it tells us that that is F6.